Welcome to a new deep dive. We've got this really fascinating stack of sources today. Leaked blueprints, supply chain analyses, physics research papers.
So yeah, it's a huge stack today.
Right. And they all point to this mind-bending new facility rising in the Texas plains dubbed Terafab. I mean, it's a 2-nanometer chip factory being built completely from scratch.
And the ambition here is just staggering. I mean, the goal isn't just to make chips, right? It's to produce 1 terawatt of AI compute per year from a single location.
Wow.
Yeah, which means they're totally defying decades of established semiconductor manufacturing rules and honestly risking billions on extreme vertical integration.
Okay, let's unpack this, because the physical roadblocks to hitting that 1 terawatt scale are honestly wild. Let's look at the math in these supply chain reports. This factory requires over 300 EUV lithography machines.
Right, those are the $150 million devices, yeah.
Exactly, the ones that use extreme ultraviolet light to literally draw circuits at the atomic level. But here's where I'm stuck. The only manufacturer on Earth, ASML, produces just 50 of them a year.
Yeah, 50 total.
So how on earth do they plan to get 300? I mean, are they just going to hoard the entire global supply for 6 years? That math just doesn't add up.
It doesn't, and that is exactly the bottleneck.
Right.
It really highlights the sheer audacity of the gamble here. They are attempting a near hostile takeover of the supply chain. What's fascinating here is the unprecedented fragility this creates.
Fragility because they're doing it all in one spot.
Right. They're trying to combine logic, memory, packaging, and testing.
All under one roof.
Exactly.
Yeah.
And normally those processes are spread across multiple highly specialized companies and continents.
Right, so instead of a resilient global network, they're putting all their eggs in one massive Texas basket. It's like trying to build a commercial airliner where instead of buying parts from experts, you're trying to smelt the titanium for the engines and weave the carbon fiber in the exact same hangar where you're calibrating highly sensitive navigation optics.
That is a great way to picture it, yeah.
One localized disaster or even cross-contamination between those processes, and you ruin the entire yield. So with physical risks that immense, why take the gamble?
Well, because the alternative is waiting in line.
Yeah.
And right now, waiting is economically fatal. TSMC, the world's leading chip manufacturer, is booked out 3 solid years in advance.
3 years?
Yeah. And in the current technology race, waiting 3 years means you lose all your market momentum. But the deeper reason is this fundamental shift in the industry. Today, chips aren't just a component inside a device. They actually are the product.
Yeah, and looking at the financial projections in our notes, the cost savings of bringing it all in-house are just massive. They estimate saving $1,000 per car.
Which adds up fast.
Oh, incredibly fast. If
Right.
you scale that to a planned robotaxi fleet of, say, 10 million vehicles, that's $5 billion saved every single year.
It's unbelievable.
But the part of the research that really threw me was that cars aren't even the main focus. Up to 80% of these silicon wafers are actually destined for space, specifically for networks like Starlink and SpaceX.
Which completely shifts the economics. Standard radiation-hardened space chips can cost up to $10,000 each.
$10,000 for one chip.
Right, because they require intense testing and suffer from incredibly low yields. But by controlling the entire manufacturing stat from start to finish in-house, they project they can drop that cost down to just $300 to $500 a chip.
Here's where it gets really interesting, because great economics on a spreadsheet mean absolutely nothing if atomic physics gets in the way.
Very true.
I was reading through these industry rumors about a so-called dirty fab. The idea was that to save money and move fast, they might relax strict clean room standards, automate everything with robots, and literally let technicians eat a cheeseburger while the chips are printing. That sounds like a complete mechanical disaster.
It is a fatal trap.
Yeah.
And those rumors severely underestimate the physics involved. At the 2-nanometer scale, they are moving to what are called 3D gate-all-around transistors.
Gate-all-around.
Yeah, these structures literally wrap the conductive channel on all sides, just to prevent power from leaking at the atomic level. They are incredibly fragile.
So a single invisible dust particle landing on a circuit isn't just a speck. At that microscopic scale, it's like a massive asteroid slamming into the chip, right?
Precisely. It destroys the entire circuit. You simply cannot run a dirty fab when you are engineering at the atomic level. That harsh reality explains why they quietly formed a new strategic partnership with Intel.
Oh, to get some help?
Right. They realized they desperately needed to borrow decades of real, hard-won, clean-room manufacturing experience just to stabilize this incredibly sensitive environment.
So what does this all mean? If this factory fails, the ripple effect hits everything from the price of the car in your driveway to the satellite internet on your phone.
If we connect this to the bigger picture, you are witnessing a massive cyclical shift. We are moving away from hyper-specialization and back to the extreme vertical integration of old tech giants.
Right, doing everything yourself.
Exactly. It's a duality. This project is either a stroke of absolute genius or a brutally expensive trap. But whichever it is, it will dictate the cost, speed, and availability of the tech you use daily.
It really leaves you with a pretty wild thought. If this hyper-concentrated, vertically integrated mega factory actually succeeds, does the traditional, highly specialized global supply chain become totally obsolete?
It's a very real possibility.
It makes you wonder if every major tech giant will soon be forced to build their own massive silicon cities just to survive.